Hello everyone, today we'll continue looking at the AWS question bank. Next we're on question 11. This question is about a database on our ECR instance. Currently, the ECR instance connects to the database using a username and password stored in a file. The question is, how can we most simply manage our credentials and minimize overhead? How should we choose a solution here? First, option A is
If you want to learn Kubernetes technology or get the CKS question bank, please send me a private message. You can also leave a comment below the video to discuss technology.
It can automatically rotate credentials without manual intervention, greatly reducing our operational overhead. So, option A is fine. Option B is also about enabling automatic rotation, but this time using parameter store. While it can encrypt stored parameters, it does not support automatic rotation. Rotation requires custom scripts or manual operations, which increases overhead. It meets the requirements, but the overhead is slightly higher than option A. Option C is to migrate the credential file to an encrypted S3 bucket. There's no issue with security in this case, but the credentials are still managed manually, so automatic rotation can't be achieved. Option D is to migrate the credential file to our encrypted EBS volume. This changes the storage location, but still doesn't solve the manual operation issue. If manual management isn't addressed, it doesn't fully meet our requirements. So, in the end, we choose option A. The automatic rotation feature of Secrets Manager can best minimize our operational overhead. That's our answer for question 11. Next, let's carefully take a look at question number 12. Question number 12 is specifically about a web application that is currently hosted on our existing EC2 instances. These particular instances are securely located behind our robust application load balancer, and within our comprehensive application, there is some essential static data and some dynamic, ever-changing data that is constantly being updated. Currently, our primary and most important requirement is actually this very specific and crucial point. First, the company wants to store our static data in a storage bucket. The main goal is to improve the performance of both static and dynamic data, reduce latency, and also to use a custom domain name with Route 53.
If you want to learn Kubernetes technology or get the CKS question bank, please send me a private message. You can also leave a comment below the video to discuss technology.
There are quite a few requirements, so let's look at them one by one. First, let's look at option A. It involves creating a CloudFront distribution using an S3 bucket and an ALB load balancer as the configuration, and setting up our Route 53 to point to CloudFront. First of all, CloudFront is a CDN service. The main feature of a CDN is, of course, to reduce latency, right? It's designed to reduce latency by delivering content from edge nodes, and it can also forward dynamic requests to our ALB to optimize overall delivery. Finally, Route 53 resolves and routes traffic to our CloudFront, achieving accelerated access. This fully meets our requirements. Now, option B is to create CloudFront with ALB as the origin, and in addition, it adds a global distribution. This is mainly used for what? It's used to accelerate network access to our AWS resources. However, when it comes to S3, what do we usually use for acceleration? Typically, we use CloudFront to accelerate, using S3 as the global content endpoint, which actually isn't very common, and the solution is relatively complex, so it's not used much in practice. So although here it mentions creating CloudFront with S3 as the origin, and then using ALB and CloudFront as endpoints, first of all, CloudFront itself is already a global service, so it doesn't need to be accelerated through Global Accelerator. Doing so actually adds unnecessary complexity. Then the fourth option, DX, uses two domain names that point separately to CloudFront and Global Accelerator. In this way, static and dynamic content are separated, but this also increases some management overhead, and the user experience may be inconsistent. Moreover, CloudFront itself can handle both dynamic and static resources at the same time, so there is actually no need to separate them here. Therefore, for question 12, we choose option A. Next, let's look at question 13. Question 13 is about a company that needs to perform some maintenance on our AWS infrastructure every month. During maintenance, they need to rotate MySQL database credentials across multiple AWS regions. How do we find a solution with the lowest cost? Actually, you can notice that whenever a question is about finding a solution, there is always a condition, the lowest cost. This is a condition that must be met. So here, pay attention to how to minimize the cost. So what does filtering mean here? It basically means that, first of all, you should try not to use too many services, right? Don't use too many services, and don't use services that are too complex. Try to minimize operations, and in this way the overhead will be relatively lower. But of course, the premise is that you must meet the requirements. Only after meeting the requirements should you try to reduce costs. Now, option A is about configuring multi-region replication and automatic rotation with Secret Manager. We've actually used this before, right? Secret Manager supports multi-region replication and automatic rotation, and you only need to configure it once to automatically manage rotation and replication across all regions. So the overhead here is extremely low, right? There's basically not much you need to manage. Now, option B is about using our setting manager to configure multi-region replication and rotation. First of all, it doesn't natively support this, right? If you need to customize it, the operational overhead will of course be much higher. Option C is about storing credentials in our ESS3 storage group and then using EventBridge and Lambda for rotation. In this case, you also need to write and maintain your own code, so the operational overhead is also relatively high. Option DE is about using KEMES to encrypt credentials and store them in a credentials table in our database. In this case, you also need to customize a rotation logic, which is quite complex and has a relatively high overhead. This is our question 13, so when option A alone meets the requirements, it's best to choose the simplest operational approach. Alright, next, let's look at question 14. This question is about running an e-commerce application on ECR instances. Instances in an EC2 auto-scaling group across availability zones. Now, the problem that has arisen is a decline in database performance. The database performance has dropped, and the application is handling more read requests than write requests. In other words, reads are more frequent than writes. Currently, what we're looking for is a solution that can automatically scale the database to meet the demands of unpredictable read workloads. First, let's look at option A. This one uses our Redshift single node, which is a data warehouse, right? However, a single node can't guarantee high availability, so we can't choose this option. The second option, option B, uses our RDS in a single availability zone with a read replica added. Now, the read replica here requires manual management for scaling. It doesn't scale automatically, so it also doesn't meet the requirements. Finally, we have the multi-availability zone deployment, which is configured for automatic scaling and automatic failover. First of all, here, option C, this service supports automatically adding or removing RAID replicas, automatic read scaling, and high availability across multiple availability zones. All of these actually meet the requirements. As for option D, it uses our Elasticache and Memcache caching. In fact, can't fully replace a database. After all, it's just a cache and can't serve as a database. Also, in our instances, there may be interruptions, so it's not suitable for high availability. To be honest, overall, it can't meet our requirements for scaling or for read operations. Basically, that's the main issue, right? Caching can help us improve read speed, but it can't achieve high availability. So, for this question, our final choice should be option C. Next, let's look at question 15. Question 15 is mainly about a migration issue. It's primarily a migration issue. Right now, we need to protect the traffic going in and out of the production VPC. Now, we have an inspection server, and this inspection server needs to perform specific operations such as traffic inspection, traffic flow analysis, and traffic filtering. We need to have the same functionality within AWS. Which solution should we use? First, let's look at option A, which is a threat detection service. It's used to monitor abnormal activities, but it doesn't provide actual traffic inspection or filtering, so option A is not suitable. Option B is traffic mirroring, which can replicate traffic to inspection tools, but it requires funding to deploy and manage the inspection server, so the operational overhead is relatively high. Therefore, it's also not particularly suitable. Option C is AWS Network Firewall, and option D is AWS Firewall Manager. As you can see, both C and D are firewalls. Firewalls can handle traffic inspection and filtering. Should we specifically choose C or D? Both are firewalls. A and C refer to Network Firewall, while D refers to Firewall Manager. Here's how it works. Our network firewall is a firewall service, no problem there. It provides rule sets for packet inspection and security filtering, which can be deployed within our VPC to perform traffic inspection. That's perfectly fine. It's similar to a local inspection server. Now, the first option here is Firewall Manager, which is a firewall rule management service used for centralized management. However, it does not provide firewall functionality itself. It relies on our network firewall. So, what does it actually mean? Firewall rule management means it manages the rules, it's in charge of the rules, but the service itself is not the firewall. So when we're choosing a solution here, it definitely means that our service should be the one creating the rules, for example, to perform traffic inspection and filtering. You can't have the rules create themselves, right? If the rules create rules, then there's nothing left for the next step. So what should we choose here? We should pick option C, which is the firewall service itself. As for option D, you can't really say it's wrong, right? But what is option D? It's just the rules. And what do they belong to? Of course, they belong to our network firewall. If you only have the rules, it's actually incomplete. So option D can't be chosen. So for question 15, we choose option C. That's all for today's questions. If you need the complete question bank, you can leave a comment below to get the most stable question bank at the best price. That's it for today, everyone. Bye-bye.